All right, so when we were setting this one up yesterday, okay, we said that if we want to calculate average velocity, average speed, doesn't really make a lot of difference, okay? They both look similar. Our average velocity is our total displacement divided by the total time. Okay, and speed works similar except it's scalar, so it's our total distance divided by the total time. Okay, we don't just add the two speeds together and divide by 2. We don't do that. Right? So what we have to do is figure out all of that information. I'm going to need to know how far it goes in part 1 and part 2, as well as what are my totals. Okay, so in part 1, we're told that the garbage truck moves at a velocity of 4.0 meters per second, okay, and that's in a north direction. And it does that for 12.5 seconds. Okay, in part 2, we're told that it travels 26 meters south. So we're told its displacement during part 2, and that it does that at a velocity of 16.0 meters per second south. Okay, if I want to find average velocity, I need the total displacement and the total time. Okay, right now I don't have the displacement for part 1 or the time for part 2. So I need to calculate those two things using V equals d over t. Okay, I have V and t for part 1, so I can calculate the displacement. Right, so the displacement in part 1 will be V times t. 4 times 12.5 is 50 meters north. Okay, I think we got that far yesterday. Okay, when we calculated that displacement. Okay, so we got 50 meters north as my displacement in part 1. Okay, and then in part 2, I need to calculate the time. Well, time will be d over v, so that'll be 26 divided by 16, which I think comes out to 1.625. Is that right?
Yeah.
Seconds. All right. So now I've got the distance for each part, or sorry, the displacement for each part, and the time for each part. Can I find the totals? Can I find my total for the whole trip now? Okay. In part 1, I go 50 meters north. Then in part 2, I go 26 meters south. What's my total displacement over the whole trip? Okay, just try and visualize it. I go 50 meters north in part 1, and then I turn around and go 26 meters south. How far am I from where I started? 24 meters. Okay, 50 north minus 26 south. Okay, gives me a total displacement of 24 meters north. Okay, can I calculate my total time? Yeah, okay. Took 12.5 seconds to do part 1. And 1.625 seconds to do part 2, so my total time is going to be 14.125 seconds, I think. You can double check that, but I'm pretty sure that's the number. Okay, so now I have my total displacement and my total time. Now, I can calculate my average velocity. Okay, so my average velocity is going to be 24 meters north divided by 14.125 seconds. Oh, there it was. Okay, I erased it. 24 divided by 14.125. Okay, so we're looking at 1.7. I think we only have two significant figures here. So 1.7 meters per second. And what do I have to put on the end of that? North, exactly. Okay, so I was able to calculate the average velocity. Can I now calculate the average speed? Okay, what changes here?
Distance.
Right, the distance is going to change. Time is still going to be 14.125 seconds. That's how long the trip takes. Except now I'm not concerned with whether I went north or south, just how far I went. Okay, I went 50 meters, then 26 meters I went 76 meters. Okay, so my average speed is going to be 76 meters divided by 14.125 seconds. Okay, and that'll give me my average speed of 5.4 meters per second. Okay, no direction on that because speed is scaled. Okay. Everybody all right with that? That looks somewhat familiar. If you were in my Science 10 class, you should be nodding your head. I made you do that question. If you were in my Science 10 class at some point, you did that question. All right. So let's have you guys try the ones that are on that worksheet here. Okay, work on those for a little bit, see how we do. You're not going to get one that's like that until you get to the skydiver question on number 7. Most of them are pretty simple, straightforward calculations before that. Okay, so for number 8 here, we have a car that makes a 60-kilometer trip at an average velocity of 40 kilometers per hour. So we know the total distance, and we know the total displacement and the average velocity. Okay, so we're going to write those over here in our totals section. Okay, so our average speed, average velocity is 40 kilometers per hour, and that's north. Okay, we also know that the whole trip involves a displacement of 60 kilometers north. Okay, the trip consists of 3 parts. So we know that we're going to have part 1, part 2, and part 3 here. Okay, the car moves at a constant velocity of 25 kilometers per hour north in the first part for the first 15 kilometers. Okay, and then it goes 62 kilometers per hour north for the next 32 kilometers. Okay, and we want to know what the velocity is in part 3 if part 3 is 13 kilometers in displacement. Okay, if I'm going to find V for part 3, what else do I need? I need the time. Okay, I need the time for part 3. In fact, I don't have the time for any of them, including the total. But can I calculate it? Yes. So if I know the times for part 1 and part 2 and the total time, will that help me get the time for part 3? Yes. Okay. So the time for part 1, okay, is going to be T equals D over V. In fact, it'll be that calculation for all of them. Okay, so we'll have 25 divided by, 15 over 25. Okay, so our first one takes 0.6 hours. Okay, the second part of our trip is 32 over 62. And that is 0.516 hours. Okay, and our total time is going to be 1.5 hours, 60 over 40. Okay, 1.5. So can I figure out how long part 3 takes now? Okay, so I'm just going to add these two together and then subtract that from the total, and that will tell me the time for part 3. So 1.5 minus, okay, the answer from part 2 minus 0.6. Okay, so the last part of the trip takes 0.384 hours. Okay, now that I know that, that's my time. Now I can calculate V. Okay, V will, as always, equal displacement over time. 13 over that number will give me the speed during the last section. Okay, so that'll be 13 kilometers divided by my time for part 3, which gives me 34 kilometers per hour. Okay, so like a lot of like nitpicky calculations, none of them overly difficult, but a lot of steps kind of to get to the end there. Okay, so that's not that one, is it? Okay. Questions on that one? Any other ones we need to go over? Then we're going to move on